Today we're going to talk about the polar coordinates. So previously we talked about the curves on the rectangular coordinates, right? So the idea of these curves is how we define the points there. So if you have the rectangular coordinate system, if I would like to, so this is going to be called the x-axis, right? And this is going to be called the y-axis. And we define the points using the t coordinates, which tells me that how much distance I need to go in the x direction and how much distance I need to go in the y direction, right? For example, if I would like to draw the point with the coordinates 3 and 2, it means that I need to go 3 units here, right, on the x direction. Then I need to go 2 units here on the y direction, right? This is how we used to draw the points on the rectangular coordinates. And if I would like to find the distances or draw the curves, I need to always use the same idea of drawing the points, right? The point has the t coordinates. The first tells me how much distance I need to go from the origin in the x direction. And the second coordinate tells me how much distance I need to go in the y direction, okay? So the problem is when we are describing the circular motion, like the equations with the circles, the ellipses, or the cycloids, for example, we always are dealing with this kind of integrals with the radicals integrals, right? Do you remember? We always used to have 1 minus x squared or 1 plus x squared, the integration, and it's always difficult to do, right? So even though you can substitute this, the x with some trigonometric identity, after the integration, we always used to have difficult integral, right? For example, last time, we used to have the integral of the second cube, which is still difficult, right? So that is why the idea would be, why don't we like redefine the points, okay? Why don't we just define the points differently so that it will be easier for us to do everything which we did before, okay? To find the arc lengths, to find the surfaces, and so on, okay? So that is why we're going to define the points differently in the new coordinate system, which is going to be called a polar coordinate system, okay? So in the polar coordinate system, we have only one axis. This is going to be called as a pole. This is pole. And we are going to define the points again with the t coordinates. So every point has t coordinates. The first coordinate means the distance from the origin. This is going to be called origin. The distance from the origin until this point is going to be the first coordinate of the point. This is going to be denoted as the r. Okay? The distance from the origin until this point is the first coordinate of the point. And the second coordinate of the point is going to be called as a theta, which means what is the angle between this radius, between the point, the line which connects the point and the origin, and the pole. Okay? This angle is going to be the second coordinate of the point. We are going to define the points again with the t coordinates, but now the coordinates mean different things. Before, they used to mean like how much distance I need to go horizontally and vertically. Now they mean, the first coordinate means what is the distance between the point and the origin. And the second coordinate means what is the angle between this line which connects the origin and the point and the pole. Okay? So let's discuss a couple of examples of those points. For example, let us draw the point with the coordinates 1 and 5 pi over 4. Or let's draw the point with the coordinates 2 and 3 pi. Or 2 and minus pi over 2. Okay? Again, I'm going to put the pole, right? Then I'm going to measure the distance in the distance 1, and I need to figure out the angle, which is 5 pi over 4, right? So actually, for this case, 5 pi over 4 can be written as pi plus pi over 4, right? So if this is 0, for example, the 0 angle, where is the pi angle? So this could be the pi, right? 180 degrees, right? And pi plus pi over 4 is the half of the quarter, right? For example, this would be, so if this is the origin here, if the half is pi over 2, then the quarter is pi over 4, right? So the opposite side is pi, then where is the 5 pi over 4? It's going to be here, right? So this angle, it's going to be 5 pi over 4. Then I need to measure the distance from the origin until this point, which is going to be 1. And I can write down this point with the coordinates. 1 and 5 pi over 4. Do you understand this? So you start from the pole. You go in the counterclockwise direction. Okay? You measure the angle, which is 5 pi over 4. You will find this line, okay, which has the angle between the pole to be equal to the 5 pi over 4. Then you need to find the point, which is in the distance from the origin, 1. Okay? The distance between the point and the origin is 1. This point has the coordinates, 1 and 5 pi over 4. So let's draw the second one. Again, I'm going to put the pole. Let's find the angle, which is 3 pi. Okay? So if you start from here, let's find the distance. So let's say this is the origin, and let's say this distance is going to be 2. Okay? Now you need to rotate this line, right? So if you rotate 1 revolution around the origin, it's going to be 2 pi. Right? So where is the 3 pi? It's here, right? So this point is going to have, if you continue again, 1 more pi, it's going to be 3 pi. And this point has the coordinates 2 and 3 pi. Okay? So is it possible to describe this point using different coordinates? Is it possible to describe the same point with the different coordinates? Yes, for example, 2 and pi, it's going to be the same point with the different coordinates, right? So it appears in the polar system, we can define the same point differently, okay? So how to draw the third point? So the measure, we can measure the angles like a positive angles and the negative angles. So what does it mean minus pi over 2? What does it mean like a negative? So we just need to go in the opposite direction, okay? If you stand here and if you go in the counterclockwise direction, you measure the angle positively, okay? If you stay here and go in the clockwise direction, we're going to measure the angles negatively, okay? So minus pi over 2, it means just measure the angle, again, the same way, like pi over 2, but just go in reverse direction, okay? So if I would, so for example, the distance from the origin until this point, let's say, is 2, okay? If I go in this direction, this point here is going to be pi over 2, okay? And if I go in the clockwise direction, this angle is going to be minus pi over 2, okay? This point is pi over 2, this point is minus pi over 2. So the point here has the coordinates 2 and minus pi over 2, okay? This is how we're going to draw the points. You draw the pole, you measure the angle. If the angle is positive, you're going to go in the counterclockwise direction. If the angle is positive, right? We're going to go to the counterclockwise direction. If the angle is negative, we're going to go clockwise direction, right? So hopefully you know how the clocks are going, right? Like this, okay? So then we need to measure the distance between the point and the origin, and this is going to be the first coordinate. The angle is going to be the second coordinate of the points, okay? So now we need to learn, it's like, so we've learned about a lot of things on the rectangular coordinates, right? We first of all learned how to do the functions, and then we learned about a lot of operations over the functions, right? How to find the arc lengths, how to find the areas, tangent lines, and so on, right? So if I would like to know, now the point is like this. So I say that, hey, if I have the circular curves on the rectangular coordinates, I always used to have a lot of like difficult integrals, right? What I want is I would like to evaluate the same thing, for example, arc lengths, in the new coordinate system, in a different coordinate system, okay? In order to do this, I need to transfer all the coordinates of my points from the rectangular coordinates to the polar coordinates, okay? I need to change the units, right? For example, you can change for example, if you live in Uzbekistan, you have some money, you would like to go abroad, right? and you need to exchange your rate to the local currency, right? You need to change your money. Or for example, you measure something here in centimeters and meters. If you go to abroad, they're going to measure, for example, maybe they are measuring the same thing in miles, for example, or in pounds, right? So you need to change the units. So in order to do this, we need to know how to do this, right? If you're given one point with the coordinates 2 and 3, what are the coordinates of the same point in the polar coordinates? Okay? If you have 1,000 sims, how much money you're going to have in dollars, for example? Okay? In order to do this, let's do the following. The problem is like this. So the point is given with the coordinates x and y. Okay? So what does it mean? This distance is going to be y, right? And this distance is going to be x, right? If I connect the origin and the point, I'm going to have the triangle, right? So in the polar system, we need to understand what does it mean. So this angle is also given, okay? So this angle is given as theta. Okay? Oh, sorry. So let's do this one way. So if we're given the r and the theta, have to find x and y, then we're going to do this vice versa. Okay? So you're given the r, the distance. So r and theta. Okay? The same point was the two different coordinates. Was the coordinates x and y, and was the coordinates r and theta. Okay? R and theta is going to be the coordinates of this point in the polar system. X and y are going to be the coordinates of this point in the rectangular system. Okay? If you know, for example, r and theta, how to find x and y. If you know this distance, hypotenuse of the triangle, right? The long side of the triangle, and the angle, how to find x and y. For example, if you know r and theta, how to find y. So I know that the y divided to the r is equal to the sine of theta, right? And I also know that x divided to the r is equal to the cosine of theta, right? So I can find the y as r multiplied to the sine of theta, and x is equal to the r multiplied to the cosine of theta, right? This is the formula of finding the x and y coordinates if you know r and theta coordinates of this point, okay? So let's do an example. So let's say we're given a point with the coordinates t and pi over 3. I would like to find the coordinates of the same point in rectangular system. Okay, so this is polar. So find the coordinates of the same point in rectangular coordinate system. So if you're given r and theta, find me x and y, basically. Okay? In order to find the x, what we're going to do is we're going to just substitute the pi over 3 instead of theta, and r instead of t instead of r, right? So we can write x is equal to the r cosine of theta. So let's substitute r with the t, and cosine of theta, it's going to be cosine of pi over 3. And what is the cosine of pi over 3? It's 1 over t, right? T multiplied to the 1 over t is equal to the 1. So y is equal to r sine of theta is equal to the t multiplied to the sine of pi over 3. It's going to be t multiplied to the square root of 3 over t, which is square root of 3, right? The coordinates of the same point on the rectangular coordinates, it's going to be 1 and square root of 3, okay? The same point we represent as was 1 coordinates, t and pi over 3 in the polar system, and we represent this with the different coordinates with 1 and square root of 3 in the different system. Okay? So what to do vice versa? If you're given the coordinates of the point on the Cartesians or on the rectangular coordinates, how to find this point? So let's do one more operation here with the simplifications. So let's say x is equal to the r cosine of theta, and y is equal to the r sine of theta. Okay? So basically, if you're given the coordinates x and y, how to find r and theta? Could you please look to this image and tell me? If you're given x and y, what does it mean the r? R is the sum of the squares of the x and y coordinates of this point, right? Then take the square. Yes? Okay. Or you can show this from here as well, right? X squared plus y squared is going to be r squared cosine square of theta plus r squared sine square of theta. It's going to be r squared, right? Because if you take out the r squared, you're going to have the cosine square plus sine square, which is 1. So from here we can find the r. It's going to be the positive part of the x squared plus y squared, right? Okay. So how to find the theta from here? So let's divide y to the x, or x to the y, doesn't matter. Y to the x, what you have? R sine of theta divided to the r cosine of theta, right? Which is equal to what? To the tangent of theta. So x divided to the y divided to the x is the tangent of theta. What is the theta from here? Is arctangent of y divided to the x. Okay? So this is how we're going to find the polar coordinates of the same point if you're given the rectangular coordinates. So let's do an example. So let's say we're given a point with the coordinates 1 and minus 1. This is the rectangular coordinates. I would like to find the polar coordinates. Okay? In order to do this, I'm going to find the r. It is going to be 1 in the square, right? Plus minus 1 in the square. From the square root, it's going to be square root of 2, right? The first coordinate of this point on the polar system is going to be square root of 2. How to find the second coordinates? So the tangent of theta, I'm going to use the second equation, right? So the tangent of theta is equal to y coordinate divided to the x coordinate. What's the y coordinate here? Minus 1, right? Minus 1 is the y coordinate. And what's the x coordinate? 1, right? So the tangent of theta is equal to the minus 1, right? So what I need to do is I need to find the arctangent, right? For which value of the theta I'm going to have the minus 1? For example, at the minus pi over 2, pi over 4, right? For example, when the theta is equal to the minus pi over 4, right? Indeed, if you calculate the tangent of minus pi over 4, it's going to be sine of minus pi over 4 divided to the cosine of pi over 4 was the minus, right? And we know that the cosine is even function, so that is why the cosine of minus pi over 4 is equal to the cosine of pi over 4, which is equal to square root of 2 over 2, right? And the sine is the odd function, so that is why the sine of minus pi over 4 is going to be minus sine of pi over 4, right? It's going to be minus square root of 2 over 2. It's going to be minus 1. Okay? For example, if I draw this, it's going to be this point. So let's try to do this. The coordinates was the point. So I need to go to the pi over 4 units here, right? So it is roughly, like, it's exactly 1/4, half of this quarter, right? Minus pi over 4, right? So I'm going to put this point here. So this is going to be square root of 2 and minus pi over 4, okay? Because the angle between this line and the pole is going to be minus pi over 4, right? Okay. So could you please tell me, so is it the only way of representation of this point? Is it the only way to represent this point? No? For example, is it possible, if you're here, is it possible to reach this point going not in the clockwise direction like we did, right? But we can go in the counterclockwise direction, right? It would be 7 pi over 4, right? 7 pi over 4, right? For example, this angle, if we go in the counterclockwise direction, would be 7 pi over 4, right? Because in general, in total, until the same point, it's going to be 8 pi over 4, right? 2 pi. Like if you're like subtract the pi over 4, you're going to have 7 pi over 4. So the same point can be represented with the different coordinates, right? Square root of t and 7 pi over 4. Okay? Or, for example, you can just add t pi to the 7 pi over 4, and you're going to get, again, the same point, right? And the polar coordinates, we can represent the same point with the different coordinates. Okay? That's the conclusion. So now, is it clear for you how to change the units? If you're given a point on the polar, how to find the rectangular, right? Using the formula of the x is equal to the r cos sine of theta, y is equal to the r sine of theta. If you're given the rectangular coordinates, then you need to use these two formulas in order to find the polar coordinates of the same point.